Okay, well, thank you very much for that kind introduction. Thank you all for having me here. The title of my talk is Plants Are Trying to Kill You, which of course is a very provocative title and is meant to be, but it's trying to make people think about, obviously this community knows full well about the danger of carbohydrates, how this changes us metabolically and physically and biologically, can cause a lot of harm. But we need to remember as well that there are other chemicals and toxins that exist in the food that we eat that can also cause harm. So let's take a think about this. Okay, so just Botany 101, plants are living organisms and they like to stay living organisms. If you eat them, they die. And so they have defenses just like any other living organism. And while animals can run away or fight back, plants can't. And so they use a lot of different things, but poison is one of their main deterrents. They use these defense chemicals to poison the animals that are trying to eat them. And they have hundreds of different ones geared towards different animals, insects, and pathogens that are trying to eat them. This is why most plants in the world are inedible. We sort of know this intuitively. If you got lost in the woods here and you ran out of food, you wouldn't be able to eat any random plant. Most of them would make you very sick. I don't think anyone is going to be able to spot the vegetables in this picture, right? So you have to know exactly what to eat, and the reason is because there are these defense chemicals. So here are just a few sort of categories of the ways that plants defend themselves. They use lectins. It's something that people are gaining more interest in, but there's tons of different kinds of lectins. There's 2,500 different plants use cyanide that we know of. There's different various toxins, phytates, tannins, oxalates, hormone disruptors, nutrient blockers, things that make you very sensitive to light. And nightshades we've known about for thousands of years, and yet for some reason we're still eating these things. So again, just Botany, Biology 101, I literally learned this in 7th grade, that plants and animals are in an evolutionary arms race. Plants becoming more and more poisonous so less and less animals can eat them so that they can survive and thrive. And animals becoming more and more adapted to the specific poisons in specific plants so that they can eat that plant and survive and thrive. And this is where they get their dedicated food resources. This is like koalas and pandas. They eat a very specific diet. They eat other plants. They will get very sick. The way I came to the way of eating that I do, which is really just meat and water, is 22 years ago when I was taking cancer biology at the University of Washington in Seattle. We went over how plants use defense chemicals in order to defend themselves, but we were looking at this from a cancer perspective, so we were looking at carcinogens. And we learned 20 years ago that Brussels sprouts alone had over 136 identified human carcinogens in them. And that just, white cat, I'm telling you, this is why kids, no one likes Brussels sprouts, right? And that's why, right? That bad taste, that bitter taste is your brain and your tongue, which are sophisticated machines, and they can tell you, like, hey, this is bad for you, spit it out, so if you, and that's what we would normally naturally do as a kid. So you give an infant a piece of broccoli, they will hate you for it, You give them a piece of bacon, and their eyes light up, right? So we were learning that, white-cap mushrooms had over 100 known carcinogens, but also spinach, kale, lettuce, celery, cabbage, cucumber, broccoli, literally given pages and pages of every plant that you've ever come across in the grocery store, and not a single one had less than 60 known human carcinogens in them. They were quite abundant. We have research from Professor Bruce Ames from Berkeley in the 1980s that actually went into this, which we'll go on to in a minute. We were quite taken aback by this, obviously. We were very, very shocked, as some of you may be right now. And I remember thinking in my head, well, but vegetables are still good for you though, right? And our professor must have just read our minds. He looked at us like, you guys aren't getting this. And he just said, I don't eat salads. I don't eat vegetables. I don't let my kids eat vegetables. Plants are trying to kill you. So I was like, right, forget plants. And I just stopped. And you go to the grocery store and everything has plants, right? Everything's either is plants or has plants in the ingredients. And I just walked around and I just came across it's eggs and meat. And I'm like, okay, well, I'll just eat eggs and meat. And that's what I did for a number of years and had massive health benefits. I was playing professional rugby while in university, and my athletic performance, as well as just my physical health, just increased dramatically. It was just night and day difference. And again, still feeling those positive results 22 years later. So that's the thing, is that most plants will kill most animals. So it's not that some plants are poisonous, some aren't. It's that all plants are poisonous. It's just that certain animals have evolved the ability to defend themselves against specific plants. But if they eat other plants, they will get sick or even die. So you have pandas and koalas, right? They eat a very specific diet. It's very, very monotonous in nature. They don't have this big, broad range of things that they eat. They eat very specific things. You know, there's 340,000 species of plant in the world. Koalas eat one. Pandas eat one. Cows, horses, grazing animals eat grasses. And they only eat specific grasses. And then the leaves that a giraffe eats are different from the leaves that a gorilla eats. Those are different from the leaves that a deer eats, and so on. And if you mix those leaves around, they all get sick or die. There are symbiosis between plants and animals. Obviously, this is an evolutionary trend in the ecosystem. You have animals co-evolving with plants. You get all the Great Plains and grasslands who evolved with the big grazing animals. They work together symbiotically. But also, you can look at fruits. We think, well, fruit, the plant wants you to eat them. Like, well, maybe not. They want something to eat them, but not necessarily you, because certain animals, when they ingest these seeds, those seeds will germinate in their intestine, and that will spawn this plant. So a good example of that is a cassowary bird here in Australia and elsewhere, and they eat about 150 different berries and fruits, and those will all kill you. And they will kill basically any other animal that eats them, because those plants want the cassowary bird to eat them, because those seeds will not germinate if they don't go through a cassowary bird first. And so if the cassowary birds leave an area, those plants and trees will die off. And we have this saying, like, don't eat the red berries. This is something that people knew, identifies like the red berries, like, don't eat those, right? So most fruits are still actually going to be toxic to humans. So this is the study from Professor Bruce Ames from Berkeley. This was published in 1989, and he showed that just the natural plants and vegetables contain 10,000 times more naturally occurring pesticides by weight than the industrial pesticides that we were using on them, and that they were orders of magnitude times more likely to cause cancer than the industrial pesticides, in this case ALAR, which they were looking at specifically. They were trying to actually get it banned, and they were saying, we got to get rid of this, this is poison, and it is. Spinach is worse. So he, at that point, identified 42 different toxins that existed in just a plethora of different plants, like everything. I mean, in the article you'll see, it's just every single plant that would exist in the produce aisle was there, and 42 toxins, 20 of which were shown to be carcinogenic in mice. Fast forward 11 years later, when I took cancer biology, we already know about 136 just in Brussels sprouts. So there's more. So even though we've talked about today about the WHO pushing fake meat and lab meat and all these sorts of things, they still have a page that you can look up that all talks about all the natural poisons that are in plants. And this natural toxins in food, as they call it, does not talk about anything that exists in actual meat, except for the aquatic biotoxins. But this is from algae. The shellfish and fish should eat the algae, and that can make that toxic. But this is why you avoid things that are infested in that area. They talk about all sorts of different things like cyanides, pyranocoumarins, lectins, solanine, mycotoxins, and much more. And they talk about poisonous mushrooms as well. Think about this. We eat mushrooms, but there are over 10,000 varieties of mushrooms in the world. How many of those don't kill you on the spot or give you a religious experience, right? There's like 5, right? And yet we think that because these 5 don't give us an acute stage reaction of that nature, that not only are they safe, but good for you, which I think is a bold assumption to take with your health. See, like the natural toxins can cause a variety of adverse health effects and pose a serious health threat to both humans and livestock. Some of these toxins are extremely potent. These are all things that we eat all the time. They give examples of these things. Adverse health effects can be acute poisoning, ranging from allergic reactions to severe stomach ache and diarrhea, and even death. Long-term consequences include effects on the immune, reproductive, or nervous systems, and also cancer. So, speaking earlier today about the effects of the mitochondria on cancer, all of those carcinogens in plants damage your mitochondria. So going into some of the specific categories, such as lectins. Lectins are protein that exists in many, many, many different plants. They have a bunch of different functions. They actually have lectins in animal meat as well, but they don't seem to cause any harm. Lectins, these are probably developed anti-pathogenogenic. They're very, very, very old, and so probably against pathogens and insects, but there's obviously a lot of cross-reaction with other forms of life. These are proteins that can bind to carbohydrates, and so they can bind to carbohydrates on the surface of your cells, and and this is something that's been researched more and more. Dr. Paul Mason has a really, really good lecture on just lectins that he's done at a previous Low Carb Down Under venue, and then people like Paul or Dr. Gundry wrote an entire book called The Plant Paradox, talking about how toxic lectins are, and then concluded that you should eat a plant-based diet, which I don't think I would come to that same conclusion. So we talk about a lot of carbohydrates here, how that can affect insulin, how hyperinsulinemia can cause all sorts of different problems. But what we don't necessarily know about is that certain lectins can actually bind to your insulin receptors and bind them more tightly than insulin and cause a greater insulinogenic effect. It can also bind to leptin receptors. And leptin, so this is leptin is obviously a satiety signal. So it's released from your adipose tissue and your stretch receptors. When your stomach is full, it goes to your brain and says, hey, we're full, we're hungry, or we're not hungry, we don't need to eat, we have enough energy. So you block that off, which insulin will do as well. Then you're not able to see your satiety signals and you end up overeating, and you overeat, and you overeat, and this is why we overeat. So this is another reason why people on a ketogenic diet often reduce the amount that they will eat naturally, but sometimes you'll actually see that the lectins are also having an effect, and when you drop those, people will actually lose weight as well. There was a study looking at people with isocaloric intake, and one just removed lectins, and they all lost weight, and the others didn't, and it lost a significant amount of weight. It's also implicated in things like Parkinson's disease. They actually found that lectins can actually track up the vagus nerve and get into the substantia nigra and damage your cells there, and are implicated and thought to be a part of Parkinson's, or at least a contributing factor to Parkinson's. Demonstrating this, there was a study in 2015 out of Denmark where they looked at all the people who had a vagotomy, where they cut the vagus nerve between the 1970s and the 1990s, sort of mid, and they found that in this population there was a 67% reduction in Parkinson's rates. Interesting. Going on with lectins, there's wheat germ agglutinin, which I'm sure a lot of people are familiar with. This is another lectin. This can bind to the carbohydrate surface antigens on your enterocytes in your intestinal lining, and this can damage them. It can destroy them. It will also destroy these tight junctions where these cells are literally stuck together and giving barrier protection against things getting in your body that aren't supposed to get in your body. So when you damage those tight junctions, now bacteria and other chemicals that would normally not get into your system, like lectins, will now get into your system and cause all sorts of problems, like binding to your insulin receptors. Lipopolysaccharides are coming from bacteria, can also bind the toll-like receptors, and this causes an inflammatory cascade. And they can also, through molecular mimicry, is now implicated in autoimmune diseases. So these lectins obviously are foreign agents. They get into your body, and your body doesn't like that, and so it attacks them with antibodies. Some people, the genetically susceptible, sometimes they have surface antigens that look similar to these lectins and other foreign objects, and so now there's a spillover effect of these antibodies that now attack your normal cells. And this can be demonstrated as far back as the 1800s with Dr. J.H. Salisbury, for whom the Salisbury steak was named after, who did a 30-year research project into optimal nutrition for human beings and wrote an entire book called The Relation Between Alimentation and Disease, basically saying the relationship between disease and what you eat, which is my entire argument. This has been made before. And he found that this was long before processed sugar, that he found that people that stopped eating plants, just ate a pure meat and water diet, really you advocated red meat and water, were reversing things like rheumatoid arthritis, Crohn's, ulcerative colitis. This was a century before we had any significant medications that would help. This was devastating when you got this. And And he found that people would reverse it. People today are doing this all over the world. People may know of Jordan Peterson, his daughter Michaela Peterson, who had such severe juvenile rheumatoid arthritis that she had 2 joint replacements of her ankle and I believe her hip when she was 16 years old. She eliminated she went keto first and eliminated out a lot of different toxins and nightshades in particular, and had very, very good results. Then she dropped all the salads as well, just went to pure meat and water diet. Now she's off all medications and she's having kids, and she's healthy. She has not had a single flare-up. She had salad once, and that gave her a flare-up. And so she's like, right, never doing that again, right? So that's, I think, very interesting as well. So you have these cyanogenic glycosides, and these exist in things like cassava root, which is a very important root, which we'll talk about. Also almonds and bitter almonds. They respond to damage. And so once you're chewing an almond or a bitter almond or cassava, that will release this cyanide. So it's normally not in the tissue, just when it's being damaged, right? So this is a defense mechanism. The cassava root, there's bitter and there's sweet. The sweet, or both of them combined, account for the 3rd most important source of calories in the tropics, and is the primary source of calories for over 500 million people in the world. So this is a very important source of calories, and it contains cyanide. The bitter cassava will kill you if you eat it, the amount of cyanide that it has in it. So it has to be specially processed. And they grow the bitter cassava because if they have a problem with herbivores coming around eating their crops, well, they're not going to eat this one because it'll kill them, right? And so that has to be specially processed. But it doesn't get rid of all the cyanide in it. And so long-term exposure to even low-grade cyanide can cause serious thyroid and neurological damage, and quite seriously. And so we don't have that really as a staple here, but people do eat almonds, and people don't realize that 400 to 800 grams of almonds can be a lethal dose of cyanide in an adult. And yet we give this stuff to kids and sell it in grocery stores, which I think is wild, right? And then there's bitter almonds, which are just the inside of like a peach pit or stone. You crack that open, it looks like a little shriveled up almond. That's very bitter because there's a lot of cyanide in it. And 1 or 2 of those, chewed up, crushed up, will release that cyanide, can be a lethal dose of cyanide in an adult. There are things that cause direct toxicity. Hemlock is a very well-known toxic plant. What it has is a GABA receptor antagonist, where it will block your GABA receptor and you'll have intractable seizures and be dead within minutes. Even half a leaf is enough to kill an adult. Kids that have made little whistles out of the stems in America have been known to be poisoned or even killed. It's very, very toxic. Oxalates is something that people know a bit about. They cause inflammation and damage in your body. They also bind minerals. They have been associated with kidney stones as well. Tannins, they can block digestive enzymes, slow growth, and at high doses can even cause kidney damage or liver necrosis at high enough levels. Seed oils are just poison. As soon as the oil gets out of the plant, it becomes very unstable and is very pro-inflammatory and oxidative. And there is a direct correlation with the rise in seed oils and the rise in cardiovascular disease, sort of the opposite with animal fats. And there's actually an interesting paper that I've read coming from the 1970s where they actually found that seed oils were a very good immunosuppressant, and they were saying this works great for people that are getting a kidney transplant. They're not rejecting their kidneys. The problem was they were all getting cancer, and so they had to stop that. So then you have hormone disruptors. This sounds like what it is. It disrupts your hormones. You have phytoestrogens that can have an estrogenic effect in your body. I was speaking to someone just last week, and they said that their doctor, their oncologist, because they had breast cancer, didn't want them eating red meat because of all the hormones that were in meat. But look at this. The estrogen that's in red meat, for 3 ounces of lean red meat, is about for hormone-treated cows, by the way, 3.9 nanograms of estrogen per 3 ounces, whereas the phytoestrogens in soy is over 1 million nanograms per 3 ounces. So don't eat meat. What do you replace it with? You replace it with plants that have even more phytoestrogens. And the birth control pill has about 35,000 nanograms. A fertile woman will make over 100,000 nanograms of estrogen a day. So 3.9 nanograms is really not doing anything. So this is taken out of context, and it really matters that it's taken out of that context. It's been shown. Soy has been shown to reduce reproduction in sheep, lower sperm counts, and can derange your sex hormone ratios. Nutrient blockers, these are like the tannins and the oxalates, which can bind different minerals. There are also different things that will just stop your own enzymes from working and digesting your food properly. So soy and wheat both have protease inhibitors that block your protease from your pancreas from actually breaking down normally bioavailable foods like meat. The protein that's in plants is not bioavailable. If you think about wheat, for example, 80% of the protein in wheat is gluten, and that is completely unavailable to us to be used as protein. And then what little left over is bioavailable and able to be digested is now going to be hindered by this protease inhibitor. And that wheat protease inhibitor actually also stimulates the toll-like receptor, which increases inflammation. Phytates, you have phytic acid, they're in some plants. These will bind to minerals, making mineral salts, and they will stop your body from being able to absorb these like calcium and magnesium, and then it's an unbreakable bond. We don't have the machinery to break those two apart. So when we eat these nutrients and we take in things like oxalates and tannins and phytates, we are actually not able to absorb and utilize those nutrients. So just because it says it on the packet, oh, this has this much of this nutrient, doesn't actually mean that that's available and accessible to you. And so I think that we really do need to re-examine our recommended daily allowances, because it really does matter whether or not what you're eating is going to change what you actually need to take in, because you're just not going to be absorbing certain things. And all of these RDAs were developed at a time when everyone was eating a mixed diet. Fiber. There's a lot to do with fiber, but just quickly, it can actually be a physical barrier between the enzymes and your foodstuffs that's come in, and so it can actually get in the way of that. They won't break down as much, and then there's a physical barrier between the breakdown products and the lumen of your intestine. So you won't digest and absorb as many nutrients when you're eating fiber, and this was touted to be a good thing in the 1980s. They said, oh, you eat more fiber, this will actually stop you from absorbing nutrients. Isn't that great? You'll lose weight, right? I don't know. I don't think that makes any biological evolutionary sense anyway. Certainly wouldn't give you a survival advantage to limit the amount of nutrients you're getting from food. Most animals are starving to death rather than getting fat in the wild. Photosensitivity is quite interesting. There's different furanocoumarins that I mentioned before, especially in the citrus and carrot family. And so things like limes, just the juice of limes, have these furanocoumarins in them. And then when they get on your skin, they react with light, and they are activated by light, and they will bind to proteins and DNA and cause permanent damage. And there are cases of kids who have had second-degree burns just from squeezing limes in the sun. Then you have celery and parsnips. These also have these furanocoumarins which will make you photosensitive. And celery itself, there's actually an ailment called celery dermatitis, where celery pickers and handlers, they're just picking a bunch of celery all the time, they actually get very photosensitive. They get these horrible burns like you see here. And these are pictures of a couple of sheep who have gotten into some plants that they normally wouldn't eat. Normally you see this in pasture-raised animal livestock, not wild animals. They usually know what to eat. But this is when you're stuck in a pasture, you sort of run out of the things you want to eat, so you end up eating things that you wouldn't normally, and you end up getting hurt. And so this is showing just the burns that these animals can get. Nightshades. Literally, we've known about these things being harmful for thousands of years, and yet just like belladonna, deadly nightshade, and tobacco, they use a toxin called solanine, among other things. But we regularly eat potatoes, tomatoes, eggplants, peppers, capsicums. All these things are nightshades, and they all produce solanine. What we forgot when we adopted the use of these things from the New World, from North and South America, was that the people eating them in those areas, A, were poor, didn't really have access to meat, and so they sort of had to for survival. And B, they process these things in a very specific way. The tomatoes, when they're green, they have a lot more solanine, so you had to wait for them to vine ripen. Then they would blanch them, take the skin off, take the seeds out. That's where the highest concentration of these poisons were. Potatoes, we used to peel them. Now, oh, well, that's all where all the nutrients and vitamins are, is in the skin. Like, right, that's where all the poison is too. It's a barrier protection against something going in and eating it. I think most people would have grown up with one of their parents telling them that when you have to keep potatoes in a dark cupboard, and if it would turn green, you have to throw it out. It's bad. It's bad. What does that mean? It means it's toxic. It has a toxic level of solanine in it. Or it sprouts roots, and that's bad too. You have to cut out the entire eye or throw away the whole potato because it's bad. Apparently, some people's mothers didn't tell them this. And so if you look it up, 70 people a year still die from eating potatoes. Potatoes, right? So this is just a picture of a gate of a garden in England that has cultivated and brought together a lot of these very, very toxic plants to the extent that if you get close enough to these things, they can kill you just by some of the chemicals that they're exuding. And in fact, the head groundskeeper has actually succumbed to that and died from one of the plants there. And just to jump back, think about lectins. Ricin is another lectin, right? This is a deadly poison. It comes from the sort of the skin of castor beans, and even just a few milligrams of this will kill you invariably. So, does it contain nutrients? Yes. Plants do contain nutrients. They're living things. They have things that are good for other living things. But this comes at a price, and they're also not as bioavailable as we think. This is why I think we need to redo these RDAs, because it's a very different story if you are excluding these nutrient blockers and digestive disruptors. So I think the RDAs for someone doing keto or just meat is going to be very, very different than otherwise. Does it have any vital, essential nutrients that you have to have that you cannot get from meat? Well, no, it doesn't, and we have endless examples of this going back through antiquity, but even current examples today. You have the Maasai, the Inuit, the Nanette, and all of our ancestors have lived through previous ice ages and things like that, where we didn't have access to all these different sorts of plants, and they really relied on a meat-based diet. They did fine. I've been doing this for literally decades. And there are other people that have been doing it far longer than I have, coming from a Western European background. And does it cause harm? Yes, I think that it does. I hope that I've made that point clear to you. I mean, there's thousands and thousands of different defense chemicals that these things use, and I've just sort of scratched at the surface of these. But they do. And now, why is this important to us as people and specifically doctors? Well, the fact is that these defense chemicals cause a large burden of harm and illness in the population, and we're not treating it as such. We're thinking, oh, this is a disease, we need to treat the disease. We're not recognizing this is a toxicity, we need to remove the toxin, okay, and let the body heal naturally. And we're pacing over this and saying, oh, well, here's all these treatments, not thinking what the root cause is. I'm pretty sure no one here would argue that type 2 diabetes is caused by a metformin deficiency, right? So we need to look at what's causing this, right? And I think that it's these toxins. And in animal husbandry, we actually have known about this for a long time. There are a number of different ailments that are directly attributed to the animal eating the wrong thing, such as the blind staggers, the slobbers, paralytic tongue, big head, limp neck, crazy cow syndrome. And we recognize these as coming from eating the wrong thing. I think now as doctors we need to recognize that a lot of our chronic diseases are actually plant toxicities. And what I would argue is that the so-called chronic diseases that we treat are not diseases per se, but toxicities and malnutrition. Toxic buildup of species-inappropriate diet and a lack of species-specific nutrition, namely too many plants, not enough meat. And so that's what I call just the toxin theory of modern disease. I think we're looking at this incorrectly. And because we're looking at this incorrectly, we're going to get incorrect treatment. It's just you get the wrong diagnosis in the hospital, you start someone on the wrong treatment, it's not going to help them, it's going to hurt them. And I think that's what we're doing, and that's why we're not having as very, very good results, even though we've spent billions trying to treat these diseases. They're only getting worse. And so I think that that's because we're looking at them incorrectly. So as every doctor has been saying for the last 50 years, make sure you eat your vegetables. I would say don't eat your veggies, and just at least something to think about anyway. Thank you very much.